Hi everyone, this is Miss Moore, and today we are officially starting our physics unit with our first lesson on forms of energy. Now in Science 10, the physics unit is dedicated entirely to concepts of energy, which ends up being one of 5 major units of study in Physics 11. So the concepts that we're learning here are important for senior physics, but also you're going to be practicing some skills, mathematically speaking, that will be very advantageous to you when you take senior physics. The first half of the physics unit is dedicated mainly towards the conservation of energy, which is extremely mathematical, and the second half of the unit will be dedicated to energy extraction, like where is our energy from and how does that impact the natural environment, as well as the effects of radiation. So without further ado, we're just going to dive right into forms of energy. If you are taking notes today without a copy of the lesson template in front of you, I'm going to help you by highlighting in blue the concepts that are the most important that you definitely need to record into your notes as we go. You of course don't have to write down everything, that would be so much, so please let me guide you with the highlighting so you know what you should be writing down. So for starters, you should be writing down the title of today's lesson, which is Lesson 1, Forms of Energy. Now, when we talk about energy in everyday English, we don't really mean it the same way that physicists mean it. So when I think of energy and how it's used in everyday life, I think about energy being associated with living things, like, wow, she has so much energy today, or like, oh my goodness, that puppy is so energetic. And rarely do we think of it being associated with things like cars, planes, a rolling basketball, but all of these things have different forms of energy, which we're going to be exploring throughout the unit. So the first thing we need to do is define energy. And we'll start broadly by saying that any object that is doing something or has the potential to do something has energy. By do something, we are needing to be specific as physicists. So by do something, we mean move, fall, vibrate, stretch, or accelerate. Or be converted from one form to another, which means that technically as long as something is performing an energy conversion, that's part of the definition of energy as well. So scientifically speaking, energy is the ability to do work. And work and energy are defined in tandem with each other, which means it's very difficult to separate them. What is work? Well, when work is done on an object, energy is transferred to that object. So we say work is a transfer of energy. I'm going to highlight the following sentences for you to note of importance in the notes that you're taking right now. Energy is the ability to do work, and work is a transfer of energy. So you can see that the concepts are intrinsically related, kind of like the chicken and the egg. And it doesn't help matters that they can be further confused through the units that they're measured in. So they're both measured in a unit called the joule, which is symbolized by capital J. Kinetic energy is the energy of motion. Anything that is moving has kinetic energy. So an example would be like a car speeding along a level road. Gravitational potential energy is the energy stored by an object that is sitting somewhere above Earth's surface or moving somewhere above Earth's surface. So anything that has the potential to fall has gravitational potential energy, which we're going to abbreviate as GPE because it's a lot of things to write out. So in order to gain gravitational potential energy, work has to be done on the object against gravity to lift it up into the air. So a good example of that would be rocks sitting at the edge of a cliff that could fall. Another type of potential energy is called elastic potential energy. This is the energy stored by an object that can be bent, stretched, or compressed. As long as it can then unbend, unstretch, or uncompress. So if you bend it and it can't spring back, then it cannot store elastic potential energy. A good example of this would be like stretching an elastic band, because as soon as you let go, it's going to try and unstretch itself, and therefore we say it stores elastic potential energy. The third form of potential energy is called chemical potential energy, and this is the energy stored inside chemical bonds. So at the end of our chemistry unit, when we were talking about energy, change, and reactions, and all the energy that is involved when bonds are broken and reformed, all of this belongs to the domain of chemical potential energy. A really good example of this is the chemical reaction that takes place inside a battery, which actually converts chemical potential energy into electrical energy. Next, we have thermal energy. This is the total kinetic energy of all the atoms inside an object. So to heat something up, you need to get its atoms moving faster. That's one of the ways that we get something warm, is by putting it in the microwave and bombarding it with microwaves until the energy of the atoms increases so much and they move so much that we can feel that difference, and that feels warm to us. We can also heat something by giving it electrical energy on the stove. It's the same process. Hot means atoms are moving fast. That's how our brain interprets that. Electrical energy is the energy of moving electric charges, namely electrons, which flow in conductors like copper and carry energy from the source, like the battery, to the output, like the lamp. Electromagnetic energy is the energy that travels through space in the form of waves. Sometimes electromagnetic energy is dangerous and sometimes it's not. Examples include gamma rays, X-rays, UV rays, visible light, infrared rays, and radio waves. Electromagnetic energy is sometimes referred to as light energy, but the problem with calling it light energy is that that's typically reserved for the energy carried by the visible spectrum of light. So we're going to say electromagnetic to encompass all of the different types, all the different frequencies from gamma all the way down to radio wave. Nuclear energy is the energy stored in atomic nuclei. So this is energy stored inside the nucleus of an atom, which you can release when you split atoms apart, like at this nuclear power plant in the picture where there's nuclear fission being used to generate electrical energy to supply human communities with. Mechanical energy is kind of an all-encompassing term, but it's a very important concept in physics because objects can have multiple forms of energy at the same time. For example, an object could be moving, which means it has kinetic energy, and it might be storing several different forms of energy at the same time, which is potential energy. The sum of any object's kinetic and potential energy is the mechanical energy of that object. So we define mechanical energy as follows mathematically. I'm just going to use capital E to abbreviate energy. Mechanical energy equals kinetic energy plus potential energy. Let's consider these two questions here by thinking about them a little on your own before I give you the answers. The first question is, where does the energy come from that allows a student to do work on their backpack by carrying it up a flight of stairs? So in order for the backpack to get from the bottom of the staircase to the top, you had to lift it. You had to do work on it to get it there. And my hint is that the student does work against gravity when carrying their backpack up the stairs, and this work requires energy because work is the transfer of energy. So energy must be involved with this process. And the second question is, a piece of bread and a basketball are dropped at the same time onto a hard floor. Why does the basketball bounce back up and the bread just lands on the floor and lies there? So please pause the video here and think about these for a few minutes. Okay, so where does the energy come from that allows a student to do work on their backpack? The energy comes from your muscles. But muscles are not a form of energy. So where do your muscles get the energy from to do this work? The muscles receive energy from the food that you eat. Specifically, the type of energy they receive is chemical potential energy. But where does this energy come from? Where does the energy in your food come from? Some of you may be vegetarian, but even if you're not, hopefully you have lots of plants in your diet. Plants get energy from the sun. Plants get their energy from solar energy or electromagnetic energy. Which they transform into chemical energy through photosynthesis. And even if you subsist mainly on animals with a big delicious steak every night, those animals had to eat plants to get their energy. So all of the energy that you get from the food you eat has entered the system of living things from the sun. Now let's think about the basketball. One of these items can store elastic potential energy and the other one can't. And if you guess basketball, you are correct. Basketballs can store elastic potential energy. Inside the basketball is a bunch of air. And this air can be compressed. And the volume of air is kept constant because of the rubber casing, which is also a material that can store elastic potential energy. Bread contains air as well, but inside pore spaces which are voided when you squish it into a tiny pancake on the floor. So that's it for today's lesson. Please access Assignment 1 Forms of Energy, which will be due tomorrow. Bye for now.